Sharding is basically an optimization technique which involves splitting up a big database into many smaller parts. The DB is split across multiple machines to enhance the performance, availability, and load balancing of an application. We can call these machines database servers. After a certain point of scaling your applications, it is cheaper and more feasible to scale horizontally by adding more machines rather than to grow it vertically by adding beefier servers. There are many different ways to break up an application database into multiple smaller DBs. Let's have a look at some of the most popular ones. In horizontal partitioning, we put different rows into different tables. For example, if we are storing different places in a table, we can decide their locations with zip codes less than 10,000 are stored in one server and places with zip codes greater than 10,000 are stored in a separate server. This is also called range-based sharding, since we are storing different ranges of data on separate servers. The key problem with this approach is that if the value whose range is used for sharding isn't chosen carefully, then the partitioning scheme can lead to unbalanced servers. We can't assume that places will be evenly distributed across different zip codes, since there could be a lot of places in a thickly populated area like Delhi as compared to its suburb cities. Now, in vertical partitioning, we divide our data to store data related to a specific feature in their own table. For example, if we are building Instagram-like application, where we need to store data related to users, photos they upload, and people they follow. We can decide to place user information in one table, friend list in another, and photos in a third table. Vertical partitioning is straightforward to implement and has low impact on the application. The main problem though is that if our application experiences growth over time, then it may be necessary to further partition a feature specific table across various servers. It wouldn't be possible to keep storing all the pics on Instagram on a single server over the years. Now, when deciding sharding scheme for our application, we need to look at various criteria and which fits best for us. In key or hash-based partitioning, we apply a hash function to the key we are storing that yields the partition number. For example, if we have 100 DB servers, our hash function outputs a numeric value of that key and mod it by 100, which will give us the server number where we can store that record in. The fundamental problem with this approach is that it fixes the total number of DB servers, since adding new servers means changing the hash function, which would require redistribution of the entire data and hence downtime for our service. A workaround for this problem is to use consistent hashing. Now, round-robin partitioning is a very simple strategy that ensures uniform data distribution. With n partitions, the ith tuple is assigned to partition I mod n. Now, there are some common problems across all the sharding schemes. On a sharded database, there are certain extra constraints on the different operations that can be performed. Most of these constraints are due to the fact that operations across multiple tables or multiple rows in the same table will no longer run on the same server. For example, performing joins on a database which is running on one server is straightforward, but once a database is partitioned and spread across multiple machines, it is often not feasible to perform joins that span across database shards. They will not be performance efficient since data has to be compiled from multiple servers. Trying to enforce data integrity constraints such as foreign keys in a sharded database can be extremely difficult. Most of RDBMS does not support foreign keys constraints across databases on different servers. This means that applications that require referential integrity on sharded databases often have to enforce it in application code. Another problem is rebalancing. There could be many reasons we have to change our sharding scheme, such as maybe the data distribution is not uniform or there is a lot of load on one shard. In such cases, either we have to create more DB shards or have to rebalance the existing shards, which means that the partitioning scheme needs to be changed and all the existing data moves to new locations. Doing this without incurring downtime is really difficult. In most of the large-scale systems, these problems are solved to some extent using the consistent hashing.